Hello everyone, I hope you're all doing great. Along with the best wishes for the upcoming CAT, I am sharing a few important aspects for your revision. In the last part, we have seen time, speed, distance, and in this part, we will revise another important aspect of arithmetic, which is time and work. Subsequently, we'll also revise mixtures and allegations. And we'll also see actual CAT questions from these topics. So keep revising and make sure that you nail it this time. So let's begin. In this part, as I told you, we'll talk about time and work. We'll talk about the key concepts and a few questions. Let's understand absolute basics of time and work. So there are two key approaches. First approach is the unitary method approach, also called one-day work approach. Another approach is LCM approach. Primarily, these are the same. There is not much of a difference. So let's see and apply. Some people find one of them a little easier. So you can take whatever you feel or whatever you believe is easier, and you can use that method. Okay. So now A can do a work in 10 days. B can do a work in 15 days. Let's say that the work is 1 unit. That's the unitary method. So A will do 1/10 of the work in a day and B will do 1/15 of the work in a day. If they are working together, the amount of work they will do together will be 1/10 plus 1/15. If you take the LCM, how to take the LCM? Take the bigger number and see the multiples. 15. Is 15 divisible by 10? The answer is no. Next multiple 30 divisible by 10. The answer is yes. So 30 is the LCM. 10 3 times, 15 2 times. So this becomes 1/6. So if the work is 1 unit and 1 day work for combination of A and B is 1/6, so the time taken will be 1 upon 1/6, which is 6 days. That is the unitary method. Now LCM method, what does LCM method say? Let's see. Instead of taking 1 unit work, LCM method says that 10 and 15, the LCM is 30. So let's say the work is 30 units. In that case, 10 days here. So how much work in a day? 3 units per day. And for B, it will be 2 units per day. So the combination will do 5 units per day. A and B combined are doing 5 units per day. Total work is 30 units. So therefore the time taken should be 30 upon 5, which is 6 days. So I hope this is clear to you. Both unitary method and LCM method are effectively one and the same thing. But if you believe that one of them is easier, you can take that approach. Alright, let's see another question using both approaches. Time taken by A, B and C to complete a work alone is 4, 6 and 12. So let's say go by unitary method first. Work is 1 unit. In that case, 1 day work for A will be 1/4, for B will be 1/6, for C will be 1/12. Combined together, they will do it in 1/4 plus 1/6 plus 1/12. What is the LCM? LCM is 12 only. 3 times, 2 times, 1 time. So this becomes 1/2. So combined, they will do half of the work in a day. So therefore time taken should be 2 days. You can do it again using LCM method. 4, 6 and 12. LCM is 12. So let's say the work is 12 units. In that case, work done by A in a day will be 3 units, by B will be 2 units and by C will be 1 unit. The combination will do 6 units in a day and hence the time taken should be 2 units. So if you are not comfortable with fractions, if you are comfortable with integers, you can take LCM method, and if you are good with both, you can take either of them. Right? Let's move forward and see a few more aspects. The concept of partial work. You have seen some examples where people keep joining and keep leaving the work, and you have to calculate how much time is it going to take. For such problems, let's understand how do we tackle them. A and B start a work which they can complete in 10 days. So the combination can complete it in 10 days. Okay, so let's say that the work is 10 units. So the combination is doing 1 unit every day, right? B left 2 days before the scheduled completion. Now the scheduled completion was 10 days. So B left 2 days before that. So B left after 8 days. So in 8 days, 8 unit of work has been done. 2 unit of work is remaining. And it took 1 day extra. So now if A was doing it, it took 1 day extra means that took 3 days to do it. So therefore 1 day work for A will be 2 by 3 units. If 1 day work for A is 2 by 3 units and the work is 10 units, so the time taken should be 10 upon 2 upon 3, so this becomes 15 days. So the time taken for A to complete the work is 15 days. How much time will B take? Very simply, they complete the work in 10 days to working together. So 1 by 15, 1 day work of A. Let's say 1 day work of B is 1 by X and 1 day work of the combination is 1 by 10. So then 1 by X is equal to 1 by 10 minus 1 by 15. LCM is 30. 3 times 2 times 1 upon 30. So therefore X is 30. So the time taken by B to complete the work alone will be 30 days. I hope this is clear to you. Again, moving forward to the next question here. Let us see. A starts a work which he completes in 12 days. B joins 2 days later and they complete the work in the next 2 days. Very nice. So let's say that the work is 12 units. In that case, A can do it in 12 days. So A does 1 unit every day. So in 2 days, he has done 2 units and the remaining work is 10 units. Now after B joins, they completed in 2 days. So if you divide it by 2, means that they were doing 5 units every day when B joined. Now you know out of these 5, 1 unit is what A is doing every day. So 4 units is what B is doing every day. So if B is doing 4 units every day and total work is 12 units, so therefore the time taken by B to complete the work should be 3 days if he is working alone. I hope this is clear to you. Keep it as simple as possible. Time and work is very simple if you understand the basic concepts. Let's move forward and see a few more questions. Next key approach or key type of questions is MDH. In time and work, you will have close to 50-60% from here and 30-40% from MDH, or you may have some 10-15% miscellaneous problems or pipes and cisterns, etc. Let's see. 6 men, 3 women can complete a work in working 8 hours for 12 days. So effectively in this approach you define work as number of men into number of days into number of hours, right? So people into number of days into number of hours is how work is defined in this approach. Let's see. 6 men, so 6 men plus 3 women. Now that's the number of people into 12 days into 8 hours. So that is the work that I am talking about here. In how much time will 12 women complete the same work? So 12 women working 6 hours every day. So let's say X number of days into 6 hours every day. Given that efficiency of each man is twice that of woman. So let's talk about efficiency. What is efficiency? Efficiency is inversely proportional to time taken, which basically means that if efficiency of man and women is twice, the amount of work they will do in a given time is equal, right? So here I can say that efficiency of each man is twice that of woman. So therefore one man is equal to 2 women. So in the amount of time, let's say if the time is a constant, the amount of work done by man will be twice that of woman. So this will become 12 women. So this is 15 women into 12 days into 8 hours is equal to 12 women into X days into 6 hours. So let's simplify this. 12 getting cancelled, WDH getting cancelled, and what do we have? 6, 2.5, and this becomes 20. So X is equal to 20. So the number of days will be 20 here. I hope the concept of man days hours is clear. Just solve a few more questions and you will understand it very clearly. Once you understand it, it is like solving linear equations. Let's move forward a few more questions. Mixed applications. One person starts a work. Next day, one more person joins him. Next day, another person joins him. One person can complete the work in the range of 110 to 130. So we don't know exact number of days. So let us take 120 approximately. We don't know. It can be 115, 125. Don't know the exact number. Taking an approximation. Let's say 120 days. Right? So Let's say the work is being done in 120 days. Let's say the amount of work is 120 units, which means that one person can do 1 unit every day. The first day only one guy is there, so one. Second day, one more joins, so 2 units, 3 units, go on and so forth. The amount of work totally is 120 units. So if you have a look at this, this is nothing but n into n plus 1 by 2, sum of n natural numbers is equal to 120. Now understand this thing very clearly. So if you multiply here 2, this becomes 240. One quick way to solve this is approximate n into n plus 1 as equal to n square. Effectively, you approximate n plus 1 equal to n. That's just a faster way of solving this rather than getting into a quadratic equation. So n square is equal to 240. So what's the closest value of n? You know that 15 square is 225. So the closest is 225. So therefore, if you apply, let's see, if I take 15, so n into n plus 1 by 2 will be equal to 15 into 16 by 2, which becomes 120. Brilliant. So we've got, so there are, if the amount of work is 120 units, in how many days will the work be completed? 15 days. I hope this is clear to you, right? A very nice question, good question. Similar questions have come in many MBA entrance exams also, including CAT. Now in a fortress there is enough food for 100 people for n days. Okay, so 100 men into n days. Sometimes there'll be no hours. Okay, it does not have to be necessarily man days hour, right? Can be man into days, can be man into hours, right? So 100 people in n days, so 100 man into n days. 10 days later 100 more people join in. 10 days later these 100 people leave. So the additional 100 people were there for 10 days. As a result, food is exhausted 5 days later. So 10 days and then 10 days and then 5 days. So total 25 days. So the initial 100 people were there for 25 days. So 100 men into 25 days. So the total amount of work or the total amount of work to consume the food will be 3500 man days. Right? If these 100 people had not left, then the food would have lasted for how many days? Very interesting. Let us see. See, the amount of work will be a constant because the food is, the food is a constant here. There is no food being added or depleted. So 3500 man days is the amount of work to consume the food that is there in the fortress. Now initial 100 people that we have, right, in the first 10 days will consume 100 into 10 man days. Now you will have, after 10 days you will have 200 people, and now they are not, the other 100 are not leaving, so 200 men into x, so 200 man days. That should be equal to the amount of food, 3500. So if you just solve this, this is 1000, this is 3500, so this becomes 2500, and you have 200 into x, so you just cancel it, so x becomes 12.5 days. I hope this is clear to you. Again, a very interesting, very nice question from man days hour concept. Let's move forward and see pipes and cisterns. I hope you're all paying attention. I hope you're all alert. Let's see. There is a cistern of capacity 200 liters. A tap can fill the cistern in 10 hours. There is a leak at halfway mark of the cistern because of which it took 15 hours to fill the cistern. Brilliant. So the capacity is 200 liters. Find the time in which the filled cistern can be emptied if there were 3 leaks at the halfway mark. Very nice. So how to go about it? I am pretty sure many of you would have started solving. So when you get a question, don't start writing. Think about it for 10 seconds and then you start writing. Now let me give you the Sherlock moment here. All the information that is given here is just a distraction. You have a cistern that is filled and you have 3 leaks in the middle at the halfway mark. There is no way this tank is getting empty ever, right? Because these will empty the first half of the tank. For the second half there is no leak, which means that this will happen never. I hope you enjoyed it, and therefore I was asking you at the start of it, Are you paying attention or not? Now that I know that you are paying attention, let me take you to another interesting question. A drain pipe can drain a tank in 12 hours and a fill pipe can fill the tank in 6 hours, right? A total of n pipes, which include a few fill pipes and remaining drain pipes, can fill the entire tank in 2 hours. Now, to fill the tank in 2 hours, effectively you will need 3 fill pipes. But the question says that you have fill pipes also and drain pipes also. So you have effectively 3 fill pipes and you have some fill pipes and some drain pipes, which in effect will cancel out each other, right? You have X fill pipes and Y drain pipes, which in effect will cancel out each other, because finally only there are 3 fill pipes who are filling the tank in, which are filling the tank in 2 hours, right? So in that case, you have 12 here and 6 here. You know there are 3 fill pipes. Apart from this, for every fill pipe, you have 2 drain pipes so that they cancel out each other. And there can be any multiple of this number. So the general form of the answer will be equal to 3n plus 3, or because n is here, you take an x here. So the general form is 3x plus 3. How many answer options take this form? Let's see. The first one definitely does, not here, definitely not here, definitely not here. So there are 3 options possible. I hope you enjoyed this. I hope you will all check out the playlists, divided all the content into playlists so that you can, work it out accordingly. Thank you so much for joining in. God bless you all and keep preparing really hard. Thank you so much.